My name is Bogdan Iancu. I'm with the OpenSIPS project. And I have a presentation about a topic which is not completely new at all, about how to use OpenSIPS as a front-end for the Asterisk. It's a topic, there were many talks about it, but it's like a never-ending because all the time there are new possibilities, new issues to cover and so on. So I will try to approach this time this topic from the perspective of the scalability in terms of load, instead of geographical scalability, and also in terms of scalability of features. Now, because I will try to follow kind of a story during the presentation, like what's the typical evolution of a VoIP service, because in the past maybe 10 plus years, the typical evolution of a VoIP service was, okay, I start with an asterisk because it's quite quick to start with. You have all the features, so it's a quite great tool to get you started with, again, being able to offer really good complex services. So that's typically the first step, and then you're going to see later that, okay, I will probably hit some limitation and what are the solutions. So in the very beginning, I just have two questions for you. So in the very beginning, to be sure, how many of you know what OpenSIPS is, first of all? Okay, that's good. And secondly, going back to our story, like how many of you started with operating an asterisk-based system? Okay, good. So we are on the same track in that case. So typically, that's how the story ends. You have an asterisk, and you have your users hooked directly into asterisk, and everything, again, it's great because you can do a lot of things. It's easy too. You have all these, let's say, generic wrappers over asterisk in terms of PBXs to make your life easier. So again, it's an easy way to start. So from this point further, let's see what you can do in terms of the relation with OpenSIPS, because again, we are looking in addressing mainly three things. First is about scalability in terms of load. Then we're going to talk about geographical distribution, so how you can geographically distribute an asterisk-based service, and also how you can scale in terms of additional services that, for whatever reasons, may not be available on the asterisk side. So the first thing that you have to do is, of course, inserting in the middle OpenSIPS as a proxy, in the middle between your SIP user agent and the asterisk. This initial insertion, it's quite easy to be done. Typical configuration for OpenSIPS is to act as a proxy. You don't have to change more or less nothing, probably just some authorization stuff on the asterisk side, so it's quite easy to do. Also from the SIP user agents, it's quite simple. You don't have to change passwords, you don't have to change usernames or anything. You just have to point as an outbound proxy to OpenSIPS. So basically all the traffic between your SIP user agents and asterisk will go, in this case, through OpenSIPS. And again, what is the goal? Get more features, be able to scale in terms of load, and also to be able to distribute. So let's start, once we got this asterisk, let's say, okay, what have we achieved, what we can do? I mean, what's the whole idea? So starting from the lowest level, because you'll see that actually this insertion of OpenSIPS will affect more or less all the levels, like starting with network level, protocol level. You can do many things in addition at the SIP level, call level, and of course feature level. So let's start one at a time to see exactly what extra things you can do by the simple fact of putting your OpenSIPS in there. Again, in this very first step, we still have a single asterisk box, so we are not talking about balancing. That would be step number 2. So again, network level, what OpenSIPS can help you is especially dealing with different kind of network topology. like you have maybe Asterisk running and you want to run it in a private network, so you need something to do the actual bridging at IP level for the SIP traffic between the endpoints and Asterisk. So in that case, OpenSIPS can take over such a job. You may have the situation where actually OpenSIPS sits between the networks, so it has interfaces in both public and private network. But in the same time, you can have also the scenario where also OpenSIPS sits behind the NAT, so in the private network, and it's still able to traverse the NATs in order to be reachable and, of course, to reach back the SIP user agents. So in such scenario where you keep Asterisk completely private, you may address different issues related to the IP network topology. Moving on, transport layer. Well, in most of the cases, all the configurations on Asterisk do rely on the UDP, using UDP for the SIP protocol. In the same time, there are needs to use something else on the user side, like TLS, TCP, or web socket. So in such a case, OpenSIPS can act as a translator between these protocols, and not only a SIP translator. If we look, for example, for the TLS, so looking forward further than the simple encryption, we can look into how to achieve authentication using the TLS, the SSL certificates. So OpenSIPS has a quite powerful mechanism to handle multiple certificates. You can do dynamic mappings between certificates and SIP domains, or even if you have a single SIP listener. So we are using the SNI support in order to figure out in advance what kind of a SIP domain is advertising during the TLS setup, so we can present different certificates for different customers. So you can have multiple customers reaching your OpenSIPS with different certificates. OpenSIPS will be able to manage. All the TLS certificates management, it's nicely done through the database. You can reload, easy to provision, and so on. So it will solve you a lot of headaches if you want, let's say, to improve your setup with some security layers like the TLS. With a WebSocket, you have the full support to translate WebSocket and secure WebSocket. So again, the whole idea with almost no kind of changes on the Asterisk side, you can enable all these protocols in a very, very simple way by just having the OpenSIPS in the middle. Now, moving to more complex SIP level. Some interesting addition that we have starting with the OpenSIPS 2.3 is the so-called mid-registration module. Basically, even if we allow the registrations to go all the way to Asterisk, so we are not getting our hands on, let's say, on the traffic in terms of performing authentication, or we are not interfering with the registration process, because again, the whole idea is to keep Asterisk as it is, so with a minimum set of changes. So basically, OpenSIPS is not aware of the users, domains, or whatever you have configured, dial plan, or whatever you have configured on the Asterisk. Nevertheless, completely unaware of all these, OpenSIPS can do what we call registration throttling. Basically, that's a very simple way of offloading the load, the registration load on Asterisk. And basically, we are, in this throttling scenario, we are simply prolonging the registration for the expiring for the registration. So like in this example, you have an end device which registers every 60 seconds. With all the mobile devices in our days, that's a typical case. So whatever SIP client you run on a mobile device, it will do roughly 60-second registration just to be able to go through NAT to avoid any kind of extra pinging and things like that. Well, if we propagate all those registrations to Asterisk, that will be like quite a high volume of registration, not to mention that all of them needs to be authenticated. So basically the traffic is double. So what we do, we are able to actually transform this 60 seconds registration into 1 hour registration on the Asterisk side, without losing any kind of registration status or consistency on the Asterisk. So it will be more or less the same visibility on the registration itself, but we are able to prolong this registration. So we get a quite nice offloading in terms of processing of registrations. So we have here the original register, and all the other ones will be absorbed until the 1 hour is done, and then it will register again into Asterisk. Of course, if the device doesn't register anymore or it's unregistered, this will be reflected on the Asterisk. So we'll still have accurate registration on the Asterisk side. Another thing that you can achieve with the mid-registration is what we called the contact aggregation. Basically, shortly said, is we can take care and deal with the parallel forking. So multiple devices registered under the same address of record. In a typical way, so if we don't do nothing, we have like these 3 devices belonging to Alice. All of them will register completely independent into Asterisk. And when you have a call, Asterisk will be responsible for actually doing the parallel forking. So that's the typical traffic if, let's say, OpenSIPS will not do anything to address this aggregation. With the aggregation, OpenSIPS will actually detect the fact that all this registration belongs to the same address of record, and it will map them over the single registration into Asterisk. So in this case, again, we reduce a lot of traffic, and also all the processing related to the call, because in this case, from Asterisk perspective, will be one call, and OpenSIPS will be the one performing the parallel forking. So again, if you don't have such support, or if you simply want, again, to get rid of traffic, you can have this. Both features provided by the mid-registration module. Moving on, looking to other kind of things that you can do at the SIP level, you have a lot of capabilities in terms of performing traffic shaping, like applying limits, calls per second, concurrent call, or controlling the traffic burst. So all these you can do quite easily right now in OpenSIPS. We had cases where with the OpenSIPS Front-End, we had actually to control the registration process. There were like the customers mapped on Asterisk were like some medium size schools or different kind of such facilities. And the idea is they, for whatever reasons, they were registering all of them in the same time. So there was a lot of quite huge burst in traffic with, let's say, maybe 1,000 registrations coming all the same at the same time. So we had to deal with that in OpenSIPS to try to throttle it down to a rate that it's convenient for Asterisk in order to handle. So that's another thing that may improve your setup. Because I keep talking about offloading and maybe also about achieving some new functionalities, looking into the presence stuff. Probably, as you know, presence is a very generic mechanism actually to exchange information. So we have regular end-user presence, we have the BLF presence, we have the message waiting indication. All of them are actually presence, so it's the same mechanism. And you have a lot of flexibility in OpenSIPS to say, okay, if it's an end-user presence, OpenSIPS is a great presence server. So it makes no sense to send all this traffic into Asterisk, because basically there is no value in the Asterisk routing. So it's just extra processing. So in that case, OpenSIPS can take care of this presence-related user traffic locally, offloading Asterisk. In the same time, there is presence-related traffic, like the message waiting indication, that we want actually to be forward it to Asterisk because the Asterisk is the voicemail service, so it will know how to reply. So again, you have the flexibility based on the presence event to say, okay, I want to handle it local, or I will keep forwarding to Asterisk. Even more complex is the BLF. So OpenSIPS, because it has access to all the calls going through the Asterisk, in this case, OpenSIPS can take over the BLF part. Besides the actual offload, we will see in the next chapter, if you move the BLF on OpenSIPS, you also have the possibility to cluster this BLF information if you have a multi-pop setup. So something that Asterisk cannot do. I mean, you cannot see, you don't have visibilities between of the calls between the Asterisk boxes, but OpenSIPS has this ability. So even if you have multiple instances, you can cluster them, and you'll see the whole set of calls. So you get a consistent BLF information from across the whole system. Also, you can delegate on OpenSIPS a various set of features, like on the inbound, if you want. You can do a lot of dipping for, let's say, RMP, for CNAME lookup. So again, without touching anything on the Asterisk, we have a lot of mechanisms in OpenSIPS. You can do this kind of dipping through SIPs, through REST requests, or whatever. So you have quite a powerful way to integrate with other third parties in order to get extra information. On the outbound part, because we'll keep talking about users, but also carriers will be, I mean, if you do termination on your Asterisk, you will have OpenSIPS will also stay in the path between the Asterisk and the carriers, presenting the OpenSIPS IPs. And in that case, a lot of things related to the routing to carriers can be performed on the OpenSIPS, like least cost routing combined with gateway failover, or even quality-based routing, dynamic quality-based routing, by learning what are the traffic parameters for each gateway and detecting, okay, which one is the best to be used. You can also do on the outbound side the push notification system. So there are a lot of things that, again, without touching more or less nothing on the Asterisk side, you can do on the OpenSIPS right now. And the last, but not the least, you can improve the security level of the system, because in OpenSIPS you have a lot of tools to help you in detecting possible attacks or frauds and preventing. So having access to all the traffic, we can identify potential flood attacks, or we can look at the traffic to see if it's from the SIP perspective, everything is okay, looking at syntax, looking at the dialogue consistency to be sure that everything it's consistent. There are multiple injection-based attacks like DNS poisoning injection, doing in-dialogue requests and so on, so which can be controlled and detected at the OpenSIPS level. Not to mention the fraud detection, because, okay, you secure your system, but the question is who's securing the customers, right? So in that case, definitely that's mission impossible to take care of all the customers, but at least you can implement a system like such a fraud detection to figure out when a customer was hacked and eventually suspend as soon as possible the traffic to at least limit the damage. So the fraud detection works by calling patterns, looking at different things like calling rate, do call duration, destination, what's the rating call, and so on. And against matching all this data against the profile, can say, yeah, that's normal traffic, or no, that's not normal traffic, and it might be a hack, so it may suspend accounts. So that's a quite good mechanism to take care of your customers. Now, we have all this stage one, when again we had customers, we had Asterisk, and we simply put an OpenSIPS in front. We addressed quite some issues, but now we're making one more step. We said, okay, let's cluster Asterisk. So that means let's use more than one Asterisk server. So behind OpenSIPS, we can put more than a bunch of asterisk boxes. And the immediate benefits, of course, is the horizontal scalability in this case. So you can distribute the traffic between those boxes. And also you can achieve the high availability for the asterisk boxes because you are not relying on a single box, which if something goes wrong with it, then you are doomed. So first, as an, let's say, prerequisite for this kind of a clustering, we have to say that all the asterisk has to be configured, of course, in the same way, and they need to have access more or less to the same kind of provisioning data. So all of them will see exactly the same set of users, set of conference, voicemails, or whatever you have configured in Asterisk. So they will be perfectly identical. So the question is, before talking about how to actually balance the traffic between the boxes, we have to be aware of certain constraints. It's easy to talk just about calls, but we actually need to look at the service level. And there are some services typically in an asterisk, which depend on the correlation of multiple calls. For example, you have the call transfer, the attended call transfer, where there are more than one call involved. The call pickup, the parking, the call conference. So you cannot simply do like a simply blind balancing between multiple boxes because you're going to break all these services. You cannot do a call transfer if first call it's on asterisk box number 1 and the second it's on asterisk box number 2. It will not work for sure. So you need to be sure that both calls involved in the transfer are on the same box. Same with the conference or with the other services. So the question is, okay, what are the solutions to deal with these constraints? Well, the simplest solution is to try to do partitioning of your user or SIP domains between the asterisk boxes. So basically, one domain belongs to a certain box. So in that case, you guarantee that all the traffic related to a certain PBX instance is on the same box, so all the services will be together. Or we can put more stress on OpenSIPS and come up with a smarter logic that will actually be able to address all these constraints, and we will see later. So basically, with the partitioning, it's quite simple. Based on the SIP domain, whatever it's related to the A domain will go to one box, whatever it's B domain to the second box, and so on. So in this case, you will know for sure that all the services will be consistent, like all traffic related to a domain on a single box, so all the services will be fine. With the smart balancing, basically, we don't do any kind of partitioning, so whatever call may land on whatever box, asterisk box, still, OpenSIPS will do call tracking, so it will monitor all the ongoing calls, and it will try to detect the services, or calls related to certain services, and do the actual correlation. So in some scenarios, it will simply bypass the so-called load balancing logic, and it will force specific routing just to be sure that the service is consistent. So going back to the example of call transfer, let's say Alice calls Bob, this call lands on OpenSIPS. So OpenSIPS may say, okay, I don't have any information about other call involving Alice and Bob, so there is no constraint. It will simply do load balancing landing on whatever server. And then, let's say Alice wants to do an attended transfer, so Alice is calling Charlie. And when OpenSIPS gets the second call, it says, okay, hold on, I have another ongoing call from Alice, so it might be something fishy going on around here. So in that case, it will force the call to the same server, asterisk server, where the first one, the ongoing call of Alice, is anchored on. So it will send it to the same box. That's the example for call transfer. In the same way you can do, for example, for conferences. Okay, it's much simpler. All calls to the same conference number will go to a certain box. But the idea is you have a combination between generic load balancing, so simply doing balancing based on the load, in combination, again, with some dealing with special cases related to more complex services. And because we keep talking about load balancing, well, we have some nice support in OpenSIPS to work together with Asterisk. So we don't consider as load just how many calls are actually on the box. We want to actually see what's the load, let's say internal load of Asterisk, because depending on the service, 1 or 2 calls may translate into a completely different load. I mean, if it's a simply pass-through call, that's more or less peanuts. But you have like 10 calls in a single conference, in terms of CPU, that's a completely different load. So in order to get information about the real load of the box, we don't rely on the simple SIP traffic, but we also use the Asterisk management interface to query for a lot of parameters from inside Asterisk, so we can get a better view on what's going on over there. So trying to keep the balancing in terms of load, not necessarily from number of calls, but again in terms of processing, the required processing on Asterisk. So that's kind of we call it dynamic load balancing. And balancing, it's the first. Second, you need to address the high availability, and OpenSIPS can take care of this. So you can do proactive probing to the Asterisk box just to see which one is alive or not, and automatically route traffic only to the available one. Also, when trying to route a call to an Asterisk, if the call is cannot be completed because there is timeout, so basically Asterisk is not reachable, or it's rejected by a 500 because something goes terribly wrong on the Asterisk box, in that case OpenSIPS can simply reroute the call to another available Asterisk. So it may try all of boxes in the location until it's able to deliver the call to one of the boxes. You have the ability from OpenSIPS to also manually control, saying, okay, I want to disable a box. For example, if you want to do some maintenance on the box, you go in OpenSIPS, say, hey, stop using that particular Asterisk, so be no more traffic sent to it. You can take it down, fix it, improve it, whatever, put it back, re-enable the traffic to it. So you can do a lot of management of the whole Asterisk cluster. And stage 3, the last step, okay, we clustered Asterisk, and now it's the last stage is how to achieve the geographical distribution. In the last year, in a tough way, everybody learned that actually, the data centers are not so, bulletproof as we thought. So you cannot simply rely on, okay, I have 6 servers in the same data centers. Well, what happens if Hurricane Michael comes? That data center may go down. So it's not a smart move to rely on a single data center. So that's, let's say, from a high availability perspective. In the same time, you may want to do like a job balancing. So in the case in the States, you can say, okay, I have some data center in the West Coast and the East Coast. So depending on the customer location, I just want to get to the closest data center. I don't want to try, to drag all the traffic from the whole country in a single location. So there are reasons why sometimes it's good to go for a geo-distributed service. But the first question is, okay, how does the customer get to one of the POPs, right, to one of the locations? So there are 2 ways to do it. The old-fashioned way, you can use rely on GeoDNS. So based on the IP or the source IP of the users, automatically the DNS server will point to one of the servers. One of the locations. Of course, ideally the DNS server actually should return all the time after the DNS lookup should return both locations, but with different priorities, so that the end device may do the failover. If it's not able, for whatever reasons, to contact the first location, should do DNS-based failover and go for the second location. But here you rely on a bit let's say, slow mechanism like DNS. You rely on the capabilities of the SIP user agent client to be able to properly perform the DNS lookup in terms of understanding probably SRV records, priorities, to do DNS-based failover. So, okay, you put a lot of trust on the user side. So a different alternative is to use Anycast. So you address the issue on your side, not on the customer side. So what you do in this case, you offer to the endpoint as a contact IP for your platform an Anycast IP. So in this case, based either on the actual connectivity or based on different metrics that you may publish from the POPs, a router may send the traffic from a certain endpoint to one of the data centers. So from the SIP user perspective, it's very simple. It's just an IP. They don't have to do anything else. Just send traffic to an IP. You do all the magic at the network level. In such scenarios, you have to hook together the OpenSIPs that you have in the data centers, because they have to work together in order to deal with the Anycast. They will have to work together in terms of sharing information about the ongoing calls, about different kind of transactions, because in some cases, a simple transactions or a call may be, let's say, spread across the two data centers. So there is no guarantee at the IP level that all the packages related to a call will get to a single location. They may get to both or whatever number of locations you have. So just an idea to see how the Anycast works with OpenSIPS, because there is a special support in order to be able to reassemble the transaction and the call in a stateful way. So having these three locations with the front Anycast IP towards the user, and we have the boxes, the asterisk boxes. So we have the invite landing on one of the locations. Transaction is established, but when the ACK for the users, being a completely separate package, may simply go through a different location. And in that case, the dialog information, which is replicated between all the OpenSIPS boxes, will know, hey, this ACK is part of the call which was actually started through a different location. It will put all the information together, and from the Asterisk perspective, it will receive all the packages related to that call. Even worse, let's say buy may go again on a completely different location. So it doesn't really matter if you use the Anycast for what we call a more static Anycast for just high availability, or you can use it in a more dynamic way for maybe balancing traffic. The OpenSIPS layer will guarantee that the traffic will be routed in a consistent way to your Asterisk box. So basically, the Asterisk layer will not be affected at all by the presence of this Anycast interface. So when you do the geo-distribution, you have to take into consideration that you may have traffic going between the locations. So in the previous scenario, when you had a single location, you had OpenSIPS and a bunch of Asterisk servers. So we duplicated, but because of these constraints we talked before, like different services requiring you to group calls on a certain box, you may have traffic going between the POPs. So an OpenSIPS from location 1 may have to go all the way to an Asterisk located in a completely data center, because maybe, let's say a conference may be over there. So if you have a user dialing through the West Coast and the conference is already starting on the East Coast POP, you have to internally route the call. So OpenSIPS will internally route the call through all the way to the proper, let's take this example. So dialing, then in this case, let's say the conference is a fresh one. It will simply do load balancing. It will choose all the time the load balancing will be done on the Asterisk servers which are closer in the same location with. So if there are no constraints, load balancing is done over the local set of asterisk boxes. So that's fine. But now we have a second user dialing the same conference, going through a different location, and that OpenSIPS will say, hey, you know, the conference exists, thanks to the OpenSIPS cluster layer. Conference exists, it's already anchored to an asterisk box in the first data center. So it will force the call to go over there. So it's an exception for the load balancing layer. So in this case, the whole clustering support that we have in OpenSIPS will be used for sharing all the calls that you have on the system between all the locations. In that case, it will help to have consistent, let's say, call limitations in terms of calls per second, concurrent calls. All the limitations will be overall over the whole platform, not per POP, because of this dialogue sharing. That will also make the Anycast to work. In addition, for Anycast to work, we need also that sharing some transaction state. So you see there are a lot of information that are shared between all the OpenSIPS instances just in order to correlate all the different kind of state between locations and make asterisk life easier. Then we have to share a lot of information about the constraints, like that information, like where on which box the conference is anchored. So it will know that all the servers will know to send the calls to the same location. And even more, to share between all the OpenSIPS instances what's the status for the entire asterisk set. Because they will know, okay, which are active or not. It will help a lot for doing the inter-pop routing for the call. So the clustering support will take care of all this. Not to mention, of course, the mid-registration things and so on. So, because running out of time, the conclusion is in terms of using OpenSIPS as a front end. There are a couple of things that are especially addressed, like offloading in terms of processing your asterisk box by either moving services in front on OpenSIPS, either making them as easy as possible, like using the mid-registration, enabling new services, so you don't maybe sell things that are not possible to do in Asterisk. So in that case, you may try to implement them on the OpenSIPS front end. And then the two layers of scalability. First, the local clustering and redundancy for the Asterisk box, so basically the horizontal scalability. And second, achieving the geo-distribution and redundancy by using multiple POPs. And what's the most important in here is the fact that once you got your Asterisk-based service up and running, in order to do all these, you don't have to change much on the Asterisk side, so probably just some things about the IP routing. So it's quite easy to insert the OpenSIPS between the endpoints and the Asterisk boxes, and at the same time achieving all these new capabilities. So thank you, and I think it's the time for the questions. Sure. Well, I don't think it would be, let's say, needed, because as we mentioned in the very beginning, where you can do this kind of a smarter routing, so you will never end up with calls belonging to the same, let's say, transferring scenario on different boxes. OpenSIPS will take care for you to be sure that both calls will land on the same Asterisk box. So it will make Asterisk life easier. You don't have to do all this, transferring. Mm-hmm.
So it's pretty efficient with it, but my only question is, since we are using OpenSIPS, should we stop doing that and just let the system OpenSIPS manage that?
At the end of the day, it reduces to if you are able to translate the logic required, to put together the transfer calls on the same box. If you are able to implement this logic on the OpenSIPS side. So basically, if OpenSIPS has access to all the information to figure out, okay, this calls has to go there. Because if that information is, let's say, it's somewhere hidden in the asterisk, well, that would be more or less mission impossible.
Right. What about, I have an issue with attending transfers. Do I need to build a format with it and have that as part of the OpenSIPS?
No, you just have to relay the refers between endpoints. I mean, normally, OpenSIPS doesn't get involved in the actual transfer. From its perspective, there are just two calls. So.
Well, it's actually kind of free with attending transfer, because what's happening is we have a call come in, our operator has been put on hold, she makes another call, or he makes another call to an agent, they speak, and then transfers it there to there. And I see that process isn't working. I haven't gotten that working.
Well, it should work. I mean, there are no known issues. Maybe some configuration glitch or something. Yep. Other questions? Yep. Okay, so I will have my colleague Livio in 1 hour talking about more details about the clustering support in OpenSIPS, but just to give you some brief information. So the whole clustering, it's on 2 levels. We have the low level, which is simply keeping the cluster consistency in terms of communicating with the other nodes, topology of the cluster, if nodes are up and down, which this is not really resource consuming because they are just exchanging packages to see who's alive or not. Then on top of the cluster topology, you have the modules which are using the clustering support in order to exchange information. Like you have the dialog module on top, which will replicate the dialog information through the clustering layer, or the user location, the registrations, which again will replicate information across the cluster. So the question is, okay, what modules are you using in order to rely on the cluster? And secondly, how they are configured, because going back to the example with your user location, you have multiple ways of achieving clustering. You can do like full sharing. You can do like federation between the nodes. There are different ways of, let's say, sharing the information. So I wouldn't say, okay, how much is the impact? Probably the most of it is when you have a box coming alive, because that would be like a quite bulk replication of a lot of data just to be in sync with the rest of the cluster. But otherwise, all the information is exchanged in real time. We avoid using large amount of data that may, let's say, deprecate the performance of the system. So far, noticeable. There is more or less almost like a zero impact in terms of performance just because of the clustering support. Yeah, my colleague Livio, I think he will be in the other track, in the other room. Okay. Other questions? No? Okay, thank you very much.